Okay. Hello, we are Group 5 with for the summer semester of Engineering Design 2. I am Jonathan Garris, and I will let my teammates introduce themselves.
All right. Hi, everyone. My name is Killian Martins.
My name is Juan.
Hello, my name is Regal Joseph.
My name is Giovanni Nemhart.
And our project sponsor is also our professor, Professor Shuang. These are his contact information, and let's get started. So, for the table of contents, well, we're going to be discussing our project summary, our proposed solution to our issue, the system level and system level design, the implementation plan, and the organizational chart, and finally our references. So, iguanas are an invasive species in South Florida. They put a strain on the delicate ecosystem that we have here, as they provide an unfair advantage. They have an unfair advantage against native species as they compete for resources and living areas, and they are also a nuisance to humans. They are a nuisance because they damage infrastructure. When they are in their breeding cycle, they tend to burrow down into the ground, and that can mess with our own infrastructure. They're also they also damage agricultural. They eat our farms, our gardens, and whatever, and they are also carriers of diseases. So, our proposed solution to this is to develop an automated trap that uses machine learning and AI to identify the iguana when it nears the trap. We have a ultra, uh, what is it? Ultra motion sensor, I think it's yes, an ultra motion sensor that will detect the iguana and activate the camera system that we will develop using Raspberry Pi and Arduino. Um, Once the iguana is detected and confirmed to be an iguana and is in the trap, it will spring the trap and capture the iguana. And from there, they will be safely removed from the environment in a humane way.
All right. There have been quite a few advancements, specifically in the area regarding animal detection, trapping, deterrence, and there's been some research and some development that's already been done that's uh, close to what we're trying to do for this project. In 2018, there's a group in the University of California who conducted um, some research on they wanted to create a neural network to be able to identify certain animals in the wild. So instead of having to use people to look at the images and classify what kind of animal it is, they are using AI, machine learning, in order for that to happen without any human intervention. And that costs or that saves quite a bit of money and it saves a lot of time because a computer can do that a lot faster than humans can. And they were able to get an accuracy to about between 93 to 98%, which is really good. Um, our target is about 85% accuracy. So we think that it'll be pretty feasible to be able to pull off the identification system that we're going for. And also there are some commercially available pest repellents out there in the market. And one of them is called the Pest by ultrasonic animal repeller, and it basically uses a sensor to detect animal movement, and then it creates a loud noise in order to deter them. And research has shown that in the beginning, it is pretty effective. Most animals don't like loud noises, but they do tend to adapt fairly quickly. And over time, it does not become as effective. They either get used to the noise or they find some ways around it. Similar to another product called the Orbit Yard Enforcer, and it also uses motion sensor to detect animals, and it uses water to repel animals, similar to a sprinkler system. And that tends to work a little bit better, but there are also some issues. It only detects motion. It doesn't detect specific animals, on one hand. And also, when using water, it does tend to leak as well, the product, according to research. So there are definitely some cons that we're trying to alleviate with our system. There's also a patented smart trap that uses a remote control with an attached camera on it. And so a human can control this device, and they can go up to a certain animal and either spray it or use noise, similar to the previous product, in order to uh, deter certain animals. And it is more accurate because you're using a human, but the downside is also that you have to use a human, and it's not fully autonomous. So it's a little bit limited in how you can scale that certain product. There's also thermal imaging products out there, specifically for cameras that use thermal imaging, mostly for nighttime use. Um, and this will not work as well here, especially in Florida, because it's not great for hotter climates. And so it's much better to use an RGB camera. And we're mostly going to be using this during the daytime. Um, so this is not as effective here in Florida specifically, and it's definitely a more expensive technology, which we want to kind of stay away from. So to highlight our improvements that we'd like to make, we want our system to specifically detect iguanas. That's our main goal in this project. And again, we want to use machine learning, AI, to be able to accomplish that. And based on previous research done, we know that it is feasible and that we can get a pretty good accuracy um, for the detection, especially with enough training for our model. And it should reduce false positives. Iguanas are pretty distinct looking from other animals, so we should get a pretty good accuracy, and our trap should be pretty effective at capturing iguanas, especially in residential environments. This becomes very useful. And we want our system to be fully autonomous. We want it to work independently from let's say, the user or the homeowner. And, that makes it very user friendly. So, a lot of people, obviously, they are working or they're doing tasks everyday life, and they cannot be babysitting this trap. So we plan on making it as simple as possible for the homeowner. And we also want to create uh, logging. We want to be able to use an app either on the phone or on the web that logs certain events, such as when a trap has triggered, when an animal is detected, uh, or some other scenarios as well that might be useful for the homeowner, and also using timestamps so that the homeowner has all the information available that might be useful for them. And also, we want to make sure that we're following proper wildlife protocols. This trap that we're aiming to create is non-lethal and it conforms with all the bylaws here in Florida. We want to make sure that the iguanas is not being unnecessarily harmed in any way. And we also would like to, we're aiming to create this trap with everyday components that are relatively cheap. We want to make sure that we can keep the cost as low as possible to make it more accessible to as many people as possible and to be able to scale it at a reasonable rate. And we're also looking to use open source software to be able to more easily customize the software, the AI, the training tools, and that should make it more accessible as well.
All right, so the system design. So this basically block diagram shows basically the major components and how they interact. So we have our motion detection system, our vision identification system, our microcontroller, trap mechanism, event logging system, notification system, user interface, and our enclosure. So each system has their clear responsibility. So, for example, the sensor system would be responsible for motion detection, and our camera vision system or vision identification system will handle the images and the classification. So, basically, this is just our base case for this whole design, and we want to keep it first as simple as possible to make sure that it works for foremost, and after that this design will make it easier for us in the future to add improvements while keeping the same structure. Next, please. So we have our system relationship. So this is ideally how we want our system to interact with each other. So the detect motion will first, with the sensor system, will detect the motion, then it'll send the trigger to the camera vision system. And then the camera vision system would use the iguana as a key boolean as a crucial decision making system. So make sure it's a iguana, not a squirrel or raccoon or dog or whatever the case may be. The strictly iguana, and then it'll capture the image, and then it'll go through our identification process to go through multiple layers of iguanas. So iguanas come in a variety of colors: red, purple, blue, green, whatever you call it. So once it goes through that, it'll confirm it's iguana, and then it'll activate our trap control system. So this will trigger our trap, which would then go through the process and trigger the trap. So we'll have like maybe a servo, most likely a servo, closing the trap door, and then once the door is closed, it'll make sure it locks the enclosure. So that function will make sure the enclosure is safe because, like I said, we don't want to harm the iguanas. We just want to capture them. So once it's successful or not successful, either one, we'll send that to the notification system, which will go send an alert and send it to the user, and then the user will be able to go on their phone or app or website or whatever the case may be as we decide, and they'll receive notifications of the trap. And then this is our trap behavior. So our system behavior, sorry. So the process will basically say, okay, so the environment, the object, anything, whatever comes near the trap bounds would trigger the system to initiate. So the sensor system will detect the motion, then it will signal the camera, then the camera vision system would capture the image and perform the identification process. And if the process is identified, then confirm it's iguana, the system would then signal trap controller, and then trap controller activates the trap mechanism, and then notification system receives the results of the trap status, so success or fail, and then they'll send it to the user. So basically, we just want this system to be as efficient as possible. We're gonna aim for that, hopefully, like my teammate said, 85% accuracy. So that's our whole goal. And once we initiate that, then we'll further develop and make it as efficient, more efficient. So we'll try to aim for 85%, but we'll try to get to the 93 through that percent. But as of right now, 85% is our goal. But the system, we're just taking it step by step, day by day, and making it as safe and efficient and not so expensive. But that's our whole goal.
Forgot my audio. So for the implementation plan, we're going to start off with a commercially available trap. We found this trap online available on Home Depot, and what drew us towards this trap was that, as we can see right here, it has a in the back and on the bottom right here, it has this black plate that is a pressure plate system, where once the animal steps on it, it will pull down this hook that's connected to it, which is connected to another hook at the top, which will then drop the door and lock the trap. We were drawn to this one because, as we can see, this hook is independent of the upper hook, meaning this becomes a non-factor. We do not have to factor this in or try to work around the hook, as some traps are all connected and it would make it difficult to attach what we want to modify. So as I said here, there's a hook near the top, near where my mouse is, and so the idea is to attach a servo motor, which once our program identifies and confirms that it's an iguana, it will move the servo motor, which will spring the trap and hopefully trap an iguana. So as we said before, we're going to be using an ultrasonic sensor. This will detect the movements and communicate with our Raspberry Pi 5 and the camera to start image taking. And once it confirms through our programs, such as through the machine learning through like OpenCV, and it confirms it's an iguana, it'll activate the servo motor, which will trigger the trap. And as we see here, we have some extra components. We have a weatherproof case that will protect the electronics and ensure that they don't get damaged from rain or the random sprinkler. But so that's one component. We're also looking to add a cooling system, just to ensure that the heat doesn't affect the electronics in any way. And we have here that we have a USB solar panel. We also plan to implement a battery pack as our power supply system, so that way it has two sources of power. Well, if the battery pack were to fail, we have the solar panel system to help keep it alive, and vice versa. The solar panel would work in conjunction with the battery pack to ensure that it has adequate power supply. And that is our general design for the trap. And as we go along, we're going to be making changes and improvements to make the trap more efficient and our system more efficient.
All right, for the software system overview, we're planning on using pre-trained models like the YOLO V5 or the MobileNet. These models can be fine-tuned to specifically detect iguanas. To enhance the detection accuracy, we're adding multi-dimensional function algorithms that can combine data from different sensors for more reliable decision making. We're also going to set up a Python drivers for the camera, the PIR, and ultrasonic sensor to handle real-time data. The trap control system uses confined scores and proximity data to decide when to activate. It also has a safety aura to prevent harming the pets or other known targets. Next one, please. Okay, so for the user interface and communication, here we're gonna show how the user is gonna interact with the system and how everything's gonna be connected. The system will include a web-based dashboard accessible via local Wi-Fi or mobile app. From this interface, users can view the live camera feed, review past iguanas detections, and manually activate or deactivate the traps. The dashboard will also provide health indicators and tuning sliders for calibrating the sensor sensitivity. Initial setup is done via USB or a Wi-Fi hotspot. Next one, please. So for the testing, the calibration, and the validation, here we're planning on doing an extensive testing and calibration process to ensure that the system meets our design goals. First, we'll test the sensor performance across various lighting conditions and distances to ensure that the iguanas are accurately detected while minimizing the false positives from other animals or people. We'll probably use decos to simulate iguana's movement and measure how fast and reliable the trap responds. All right, next one.
All right, so we'll talk about the project management and the organizational chart. Our team leader is Killian Martin. He deals with tracking progress and updating group planners on MS Teams. And he also deals with submitting all group assignments and documents on time, as well as completing technical and written tests slash assignments. Our team organizer is Jonathan. He deals with tracking progress and updating group planners, providing feedback and support to other members, as well as get scheduling and lead team meetings on Zoom or in person. For our team members, that includes Giovanni, Regal, and Juan, who specifically deals with completing technical and written assignments. So for our team responsibility, Regal deals with the AI and vision detection, which is going to be for detecting iguanas, as well as training or using object detection models such as Yellow or OpenCVs to ensure that the camera feeds work in real time. For our trap mechanism, Jonathan will be designing and assembling the physical trap, selecting right sensors, and making sure that all mechanical components are mounted properly and function as intended. For our hardware integration, that will be Giovanni, who will be connecting the sensors, cameras, and control systems such as Raspberry Pi or microcontrollers, as well as write the code to automate the trap based on detection to ensure stable power and communication between parts. For the logging and notification system, Killian will be creating the system to log detection and trap events with timestamps and image, and implementing notifications via SMS, email, or any other method when iguanas are trapped. And for the app control, Juan will be developing a simple app or user interface that allows remote control of trap, allowing users to turn it on or off and possibly monitor status or send manual triggers if needed. So this is our development schedule, which ensures that for next semester that our team is on track and that everything is in accordance to next semester's assignment. Next slide. And these are our references for our research. Next slide. And that is all. Thank you.
I'd like to thank special thank you to our project sponsor, who's been vital in helping us determine what paths to go down. And thank you to anyone who's watching. Thank you for taking the time to review our proposal. Have a good day.